All right, today we're going to finish up chapter 5 with a concept that we call Cpctc, and we'll kind of define what that looks like here in a second. But basically what it says is that if two triangles are congruent, all their parts are congruent. And that's something we've been talking about or discussing pretty much throughout the entire chapter. And so we've actually been using this concept a lot, we just haven't actually kind of formalized it. So we're going to start here with what Cpctc means and what it stands for. So two triangles are congruent if and only if their corresponding parts are congruent. So if we can show all the parts are congruent, then the triangles are congruent. If the triangles are congruent, we can have all the parts congruent. And so Cpctc as a statement stands for corresponding parts of congruent triangles are congruent. So it just means all the parts that correspond have to be identical. And so, like I said, we've been using this concept. When I tell you that two triangles are congruent, you can use that to set up corresponding parts and solve for x. Like if I had two triangles that are congruent, and so I said this side and this side are congruent, I gave you this was x plus 10 and I gave you this was 50, I can set up an equation, x plus 10 equals 50, and then solve for x would equal 40. So that's using Cpctc. The triangles were congruent, that means these two pieces are congruent, I can go ahead and set them equal. Okay, so that's kind of the main concept. Now, as far as what we're going to do in this section, we're going to use it as it pertains to proofs. And so when we look at the proofs, these proofs are going to be almost identical to everything we've been doing so far in this chapter with proofs. We're going to be trying to prove that two triangles are congruent. We're just going to take it one step further. So notice this proof statement on this first example, it no longer says prove this triangle is congruent to this triangle. That's going to be part of the proof, but the final goal is to say that two pieces specifically are congruent within the triangles. So as I'm looking at this proof here, I started off the same as any other proof. I copy the given. So angle GKH is congruent to angle NKH. And then it also has angle G is congruent to angle N. So that's not going to change no matter what. It's always the given when we start off a proof. Now from here, if I mark the information in the picture, angle GKH is this right angle here on the top triangle, and NKH is that bottom angle. So those two angles next to each other right there are congruent. And then it says angle G up in the top left here is congruent to angle N down in the bottom left. And so what I've got is two angles and the triangles are congruent. Now notice what, again, I'm trying to prove. I'm trying to prove line GK is congruent to line NK. I'm trying to prove two parts of the triangle are congruent. I can't do that until I know the triangles are congruent. So as I'm looking here, they already gave me two angles. So if I can find one side, I know the triangles are going to be congruent. So my next step is to find a side, which we can find pretty easily right here in the middle where we have that shared side. So I can then say line HK is congruent to itself because it's a shared side. And so now I have two angles and one side. That's enough to say that the triangles are congruent, which is what I need to be able to say that the parts are congruent. So in my next statement, I'm going to say the triangles are congruent. Now again, when I make this statement, I got to match up corresponding parts. So I'm going to call that top triangle, I'm going to call it GKH. And so then when I go to name my second triangle, I got to match up corresponding parts. So G matched up with N. So I start with N. K matched up with K, so I go to K, and then H is going to go with H. So I got my two triangles congruent, and now I have to figure out why. So we said we had two angles and one side. Now notice, when I highlight the side in question, it does not touch both angles in the triangle. So that means it's not included, it's not in between the two angles. So this is going to be AAS, one of our shortcuts from the last section. And now once the triangles are congruent, my last step is exactly what they told me to prove. I can now say line GK is congruent to line NK because of Cpctc. So once the triangles are congruent, now I can go one step further and say any of the parts are going to be congruent as well. So that's all we're going to be doing. So we're going to do a couple more examples here, get you guys some more practice with the proofs. So again, I'm proving two sides of the triangle are congruent. So before I can do that, I have to get the triangles congruent to each other. So I start with the given. Angle F is congruent to angle M, and angle 1 is congruent to angle 2. So that's given to me. So angle F, marking in the picture, congruent to angle M. Angle 1 up top here, congruent to angle 2 down here. And so right again, we get 2 angles. From that, I go ahead and mark any sides that I can get. So once I have 2 angles, I need a side. So right here in the middle, again, we have a shared side. So line LP is congruent to line LP because it's a shared side. And then after that, I have 2 angles and 1 side. 2 angles and a side is enough to say the triangles are congruent. So my next step, triangle, if I call the first triangle FLP, then I need to name my second triangle, so matching up corresponding parts, I need to name it MPL to go in the same order. So triangle FLP is congruent to triangle MPL. Now we need one of our shortcuts. So I had 2 angles and a side. If I highlight that side, notice it doesn't touch both angles from the top triangle. So that means the side is not in between the angles. This is angle, angle, side. Once the triangles are congruent though, I can go ahead and say the parts are congruent. So FP is congruent to ML, and the reason would be Cpctc. Okay, and that's all it is to the proofs. We're proving the triangle is congruent, and then the parts are congruent by Cpctc. So last example here before I set you loose. If we're looking at the problem here, again, we copy the given. So in this case, I'm not going to copy this down. I'm just going to write given. You would have to copy the actual information. So we're copying the given. Now in this case, they already actually marked it for us. So angle B up top here with angle B over here, and then the 2 angles down at the bottom here are marked congruent as well. So they actually marked the picture for us, gave us 2 angles. Now if we're going to try to prove that these 2 parts are congruent, we need the triangles to be congruent. So my next step is find something else in the picture. So 2 angles were given. I notice that we have a shared side. So I mark that and write my statement. Line BD is congruent to line BD because it's a shared side. And then once I have that shared side marked, I have 2 angles and a side. And if I look at where that side is, when I highlight here, I end up touching both angles in the triangle. So I can write that the triangles are congruent. So if I call the first one, call it ABD. My second triangle would have to be triangle CBD. Match up corresponding parts. And then from there, I had the side in between. So I've got ASA. And then because of that, I can now say the parts are congruent. So line AB is congruent to line CB. And then again by Cpctc. Now one thing I want to point out before I let you go, all 3 proofs that we did in the example here were either AAS or ASA. Those were the shortcuts from the last section. That doesn't mean on your homework you might not see a side, 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 or a side, angle, side, or an HL. So all 5 shortcuts are in play here. So however you're going to get to it, you got to show that the 2 triangles are congruent, and then you can go that final step and say the parts are congruent by Cpctc. So with that, you should be able to work on the worksheet, ask questions in class, check the answer keys online, email if you have any other questions, but you should be good to go.